All right, so this is going to be a quick video on the Chapter 8 review. So I wanted you to have this information correct so that you could use it to study off of tonight. So number one, distinguish between mass and momentum. Which is inertia and which is inertia in motion? So we know that mass is inertia. So if you have more mass, you have more inertia. If you have less mass, you have less inertia. And momentum is inertia in motion, or mass in motion. 2. Which has the greater mass, a heavy truck at rest or a rolling skateboard? So if a heavy truck is at rest, then the velocity is equal to 0. So if you plug in the mass of the truck and multiply it by 0, your momentum for this heavy truck is going to be 0. So a rolling skateboard actually has more momentum than this heavy truck. So which has greater momentum? In this case, it would be the truck. Distinguish between force and impulse. So force is a push or a pull, and impulse is a force applied to an object over an amount of time. Okay, so force is a push or a pull, and impulse is the force that you apply for a given amount of time. All right, so number 4, distinguish between impact and impulse. Which designates a force and which is force multiplied by time? So impact is designated by force, so the force that you feel upon hitting something or colliding with something. And impulse is the force multiplied by time, or the force that you feel multiplied by the time that you are going to feel it. When the force of impact on an object is extended in time, does the impulse increase or decrease? So when the force of impact on an object is extended in time, then the force is decreased. So the impulse stays the same, but the force is decreased. Distinguish between impulse and momentum. Which is force times time and which is inertia in motion? So impulse is your force times time, and inertia in motion is momentum. Does impulse equal momentum or a change in momentum? So impulse equals your change in momentum. So P times your change in mass times your change in velocity. Okay, but when you're looking at an object, typically your mass doesn't change. So it's actually your velocity that is changing. So impulse equals your change in momentum. Okay, so for a constant force, suppose the duration of impact on an object is doubled. Okay, so we are doubling the duration of the impact, so we're doubling the time. How much is the impulse increased? So if we double the amount of time, then we are going to double the impulse. I'm so sorry. Yeah, if we double the time, then we're going to double the impulse. How much is the resulting change in momentum increased? Well, it's going to be increased by double or 2. Number 9, in a car crash, why is it advantageous for an occupant to extend the time during which the collision takes place? You want to do this because if you extend the impact time, or if you extend the time of which you are going to feel this force across your body, then the force is going to be decreased, which is advantageous because it keeps you alive. Why is it, if the time of impact in a collision is extended by 4 times, how much does the force of impact change? So it increases by the same amount of factor, or it decreases by the same amount of factor 4. Because if we increase the time, then we decrease the force. By which factor? Well, by 4 times. Why is it advantageous for a boxer to ride with the punch, and why should he avoid moving it into an oncoming punch? So it's advantageous to move with the punch because you are going to increase your time of impact. If you increase your impact time, then you're going to decrease the punch. If you move towards the punch, you are going to decrease the time of impact, so you are going to increase the force that you feel. In terms of momentum conservation, why does a cannon recoil when fired? So this goes back to Newton's third law, that for every action there's an equal and opposite reaction. So the force that shoots off the cannonball is the exact same amount of force that shoots off the cannon or recoils the cannon. It's just acting in opposite directions. So why does it mean to say that momentum is conserved? So momentum is conserved when there when your forces are internal to your system, just like with the cannon and cannonball, that there are no external forces or no external impulses affecting your system. And again, your system can have different objects within it, but if you count it from all within your system, and if all of the forces are within your system, then momentum is conserved. So what you start with, you are going to end with. Distinguish between an elastic and an inelastic collision. So an elastic collision does not generate heat and does not deform your materials. What it does is it actually bounces, collides, and then retracts with a certain amount of velocity. And an inelastic collision, your masses are actually going to get deformed, and there's going to be heat that is generated. So that's how we tell the difference here. Imagine that you are hovering next to a space shuttle on Earth orbit. Your buddy of equal mass, who is moving at 4 kilometers per hour with respect to the shuttle, bumps into you. If he holds onto you, how fast do you both move with respect to the ship? So for this, I have turned to my handy dandy whiteboard so that we can identify what is going on in this problem, and that we can give some mass to these people. And let's just give them a really low mass and one that is easy to work with. Let's just say that they are both 10 kilograms. And let's just say that M1, your buddy of equal mass who's moving, so let's just say that M1 is you. All right, so you're originally at rest, and your buddy here moves into you with 4 kilometers per hour with respect to this shuttle. If he holds on to you, how fast do you both move with respect to the ship? So if he is holding on to you, what type of collision is this? Well, it's inelastic. So if it's an inelastic collision, our equation is going to look like this. M1 V1 plus M2 V2. Then there's going to be a collision. Our masses are going to combine, and they're going to move away together with a certain amount of final velocity. So let's plug in our information and solve. So M1, that'd be 10 kilograms times 0 meters per second plus 10 kilograms times 4 kilometers per hour. So I should put this in kilometers per hour. Sorry. Is equal to, again, that's the collision point, our masses combined, so 10 plus 10, and then there's going to be a final velocity. So the initial momentum for you, or M1 in this case, is going to be 0 kilometers per hour plus 40 kilometers per hour is equal to 20 kilograms times VF. And again, this all stems from the idea of the conservation of momentum. So the momentum that you are starting out with initially, you need to end with finally. And again, it's about the products of these things. So what I'm going to do here is clean it up a bit by getting rid of the units. So really this is saying 40 is equal to 20 times VF. So how do we solve for VF? Well, we divide by 20 on both sides, and we get that VF is equal to 2 meters per second, or in this case, kilometers per hour. All right, so moving on to the next one. Bill fires a raw 0.8 kilogram potato out of a slingshot. It starts at rest when he lets go and leaves the slingshot going 50 meters per second for 0.2 seconds later. How much force does the slingshot exert on the potato? So we have to identify what we're given in the problem. So we were given a mass. We were given a mass of this potato was 0.8 kilograms. And it originally started from rest, so V naught equals 0 meters per second. Okay, and as it leaves the slingshot, it's going 50 meters per second, so VF 50. For how much time? Well, t is equal to 0.2 seconds. And we are asked how much force does the slingshot exert on the potato. So in order to solve these, we need to use the change in momentum is equal to impulse equation. All right, so our change in momentum is equal to mass times the change in v is equal to F times t. So now all we really need to do is plug in our information. We can solve for delta v if we want to. So delta v is equal to Vf minus V naught. So our final velocity is 50 meters per second minus 0. So we're going to get 50 meters per second as our delta v. So we can just plug that right in directly. So our mass times delta v, so I'll just plug it in now, 0.8 kilograms times 50 meters per second is equal to our force, which we're trying to find, times our time. So how do we get force? Well, we need to divide by time on both sides. Okay, so that's going to cancel out here. So we are left with force is equal to, well, you can go ahead and break out your calculator, and you should get that it's 200 newtons. All right, so 200 newtons there. All right, so our last problem here says that Sally rolls a 8-kilogram bowling ball down the alley for a league championship. A single pin is still standing and Sally hits it head-on with a velocity of 10 meters per second. The 2-kilogram pin acquires a forward velocity of 16 meters per second. What is the new velocity of the bowling ball? So if you've ever been bowling, you understand that the bowling ball and the pin don't combine into one object. They actually separate out after they collide. So this is an example of an elastic collision. Okay, and our equation for that is m1v1 plus m2v2 is equal to m1v1 final plus m2v2 final. Okay, and that's because our masses don't combine, they stay separated out. So let's identify what we're given in the problem. So I'm going to call M1 our bowling ball just because it's the first mass that we are shown. So that was 8 kilograms. And a single pin is still standing and Sally hits it head on with velocity of 10 meters per second. So our initial velocity, is equal to 10 meters per second. And our pin is 2 kilograms, and it's originally at rest. Because if you've ever been bowling, you know that the pins don't move before you hit it. And it acquires a forward velocity of 16 meters per second. So the final velocity of this pin is 16 meters per second, and we want to know what is the new velocity of the bowling ball, or what is the final velocity of the bowling ball. So let's plug in our information. So we have 8 times 10 plus 2 times 0 is equal to 8 times V1F plus 2 times 16. So if we do this math out, we're going to get 80 plus 0 is equal to 8 V1F plus 32, I believe. Yep, 32. So again, what we want to do is subtract 32 on either side. Again, this is just using the conservation of momentum. So 80 minus 32, we're going to get 48 here. Kilogram meters per second is equal to 8 kilograms times V1F. So 48 divided by 8 is 6. So V1F is 6 meters per second, and that is going to be the final velocity of the bowling ball. I hope this helped. I hope that you do well tomorrow. If you have any questions, please let me know.